we're going to continue our forces unit and talk about Newton's third law. And you've heard this before. For every action, in Newton, the word action just meant force. There is an equal and opposite reaction. And that word also just means force. Okay, don't start thinking, like in English language, we would say the reaction happens after the action. That's not the case. Every time there's a force, at the exact same moment, there is an equal and opposite force. So here's an example. I have a 10-kilogram child in a 5-kilogram wagon being pulled by an 80-kilogram father to the right before. They give you a lot of extra information. But basically what's happening is our action force could be the father pulls the wagon forward at 8 newtons. That's the action force. The reaction force, you just switched the subject with the object. Okay? So instead of the father pulling the wagon, we're going to say the wagon pulls the father backward at 8 newtons. So as the father pulls forward on the handle, he can actually feel the handle pulling back on him the same amount. Now here's an example that you might not have ever thought of. Okay, we're going to talk about the Earth. Mr. Lynch. Okay, and the force of gravity is the Earth pulling down on Mr. Lynch. So the mass is 85 kilograms. So we have to find the force of gravity. So the force of gravity, M times G, is 85 times 10, is 850 newtons. So for part A, we're going to say the Earth pulls down on Mr. Lynch at 850 newtons. So that is going to be our action force. Okay. D, the reaction force, again, I can just turn the words around. Okay, so instead of the Earth pulling down at Mr. Lynch, it's going to be Mr. Lynch pulls up on the Earth at 850 newtons. Okay? So what's going to happen is they're going to try to trick you, right? They're going to say, which feels a bigger force if Mr. Lynch, say, jumps off the table, Mr. Lynch, or the Earth? Turns out they're exactly the same force. They're equal and opposites. Okay? But which force has a bigger effect? Okay? The force on me has a bigger effect. I have a much bigger acceleration than the Earth does. We know my acceleration is going to be 9.8 downward. What's going to be the acceleration of the Earth? So in order to do that, we have to know the mass of the Earth. So the mass of the Earth is 6 times 10 to the 24th kilograms. So now to find the acceleration of the Earth, I can do F equals ma. The forces are 850 newtons. Equals mass of 6 times 10 to the 24th times a. So the acceleration of the Earth is going to be, I would take the 850 and divide it by 6 times 10 to the 24th, and I get 1.42 times 10 to the minus 22nd meters per second squared. Just to kind of put that in perspective, minus 22nd means I moved the decimal place 22 to the left. So that is the acceleration of the Earth, which is too small to be measured. Okay? But remember, the forces are the same. The force on me by the Earth pulling me down is the same as the force of me pulling up on the Earth.